right, time to explain the digital hourglass circuit. So, pretty simple circuit. We just got our tilt switch, which again, I'd probably recommend switching with a just push button switch, because shaking a breadboard circuit, often not a great idea. And we also got 6 LEDs hooked up just like we've hooked up pretty much every other LED. Each connected to a different pin. They got the 220 ohm resistor protecting it from burning out. And all this is supposed to do is every 10 minutes it lights up another light. So this guy lights up first, and after 10 minutes, after it's been turned on or reset. And then this guy will light up after 20, this guy will light up after 30, so they're all lit up here. After 40 minutes, all these 4 are lit up, and so on. So it counts up to an hourglass. That is it. That's all it does. Let's take a look how it does it. So, taking a look at the code. First, we just set up variables like normal. We start off with our switch pin. So our tilt switch was connected to pin 8, if you remember the diagram. We also need a unsigned long, because that's what we get out of millis, to hold the time of the last shaking of our circuit, or preferably button pressing. And we also need 2 things, one to hold the current state of our tilt switch, and one to hold the state of it last pass through loop. If you remember our button pressing, how to figure out if a button's just been pressed or just been released, we need those 2 variables. And we also have another variable that holds which LED we're lighting up next. So to start off with, no LEDs are lit up, and the one connected to pin 2 will be the next to light up. All right, then we got our setup methods. This is just using all our tricks we learned this unit. So we got our for method, which initializes all our pins, because who's got time to write out 6 pins or pin mode statements? Why not do it all in one go? And we're also setting the switch pin to an input, which isn't actually necessary because the digital pins default to digital input. But that's good practice because it shows other people reading your code what it does, or if it's an input or an output. Though with a name like switch pin, hopefully they can figure it out. And then every pass through loop, we create an unsigned long variable called current time and set it to the time since the Arduino started or was reset. And then we have our awesome design pattern for time triggered events, which we just learned. So we got our if statement, and so if the current time minus the time of the last event, so time since the last event, is greater than our interval we've decided on. And I missed talking about that one. We've got a long called interval, which is 600,000, which is pretty big. You're like, what's 600,000? Why'd they pick that? Well, if we divide by 1,000, it's 600. So we're dividing by 1,000 because this is in milliseconds. Divided by 1,000, we got 600 seconds. I'm like, okay, I still don't know exactly what 600 seconds is. What if we divide that by 60 to get minutes? If we divide 600 by 60, we get 10. So our interval is 10 minutes. And you can mess with that. I don't know if you want to wait an hour each time to test your code. So feel free to change that to 5,000 if you want it to happen every 5 seconds or whatever. Okay, so if it has been 10 minutes since the last time it lit up an LED, it starts counting from now. It sets the time of last event to now. So it'll be counting from now. An important part of the process. And then it lights whatever LED it was supposed to light up. And then it switches our variable, which holds what LED we want to light up next to the next one. So if this was our first pass through loop, our LED variable started at 2, so it would light up after 10 minutes. It would light up the LED connected to pin 2, and then increment our LED variable so it's set to light up the LED connected to pin 3 next time. And then this really annoys me about the code in the book. It doesn't even belong there. This does nothing. So if LED equals 7, do nothing. So what I think they were trying to do, because this doesn't automatically stop when you reach the last LED, it just keeps trying to light up LEDs beyond that. I think what they're going for was this. If LED equals 8, so if you've lit up the last LED, you've lit up the one connected to pin 7, and you're setting up to light up pin 8 next time, why don't we just set that back to 7, because there's no LEDs connected to anything further on. This probably won't cause problems because none of them are set up as outputs anyway, but I don't know, it's sort of irritating having a program trying to light up things that aren't there, mess with pins that it shouldn't be messing with. So that's what I think they're going for, and just totally forgot to do that, but I don't know. Oh, by the way, if you want to have it count down or something, something like this, and maybe like a Boolean thing that holds on whether it's moving up or moving down, something there would potentially be useful. Some if-else statement related to that. And then we also want to, every pass-through loop, we want to initialize our switch state to the current switch state. So we check out our pin connected to the switch and set our variable that holds the current state to whatever the switch is currently at. And then we've got our design pattern for if a button was just pressed or released. This doesn't discriminate. It will reset your all your LEDs. It'll wipe them all. If it's just gone from low to high or high to low, so if you've just pressed the button or just released it, this is because it's a tilt switch, so if you're shaking it, hopefully it changes state from one type to another at some point, and then you just want to reset it. And then when it does happen, when you do shake it or press the button, depending on what you're using, what you want to do is you want to turn all the LEDs off. So we could do that with 6 digital writes, but why not just do it with a 4? Use our 4 pattern. So if we got a bunch of pins in a row and we want to do the same thing to all of them, use that 4 statement. And then we're starting from the beginning again, so we need to set the next LED we want to light to 2. And then we also want to start counting from now. Every time the LED lights up, that's an event. Also, if the switch is pressed, we want to count 10 minutes from that point till we next light up an LED. So we also have to reset our count if the button gets pressed or it gets shaken or whatever it is. And then again, our design pattern for button presses, we want to set up for the next pass-through loop. So when we're done with it all, what was our current button state this time will be our previous button state for the next pass-through loop. So we got to save our current state to previous, so we're set up for our next time through. And that is how digital Hourglass works. Hopefully you got something out of this.